Students, the complete polynomials and factorization topic revision. So, the second chapter, that is polynomials and factorization, is today is a revision class. Listen carefully, all the formulas let us recollect, and after that let us stop this chapter, and after Dasara, that means on Tuesday I am going to start the new chapter. See here. First we studied what is a polynomial. See, an algebraic expression consisting variables, constant, some terms. An algebraic expression having some terms is a polynomial provided that the power of the variable should be a positive integer. For example, 2x cube plus 3x, or 2x power 3 plus 3x, or 2x power 1 by 2 plus 5, like this. If you observe the difference, all these are algebraic expressions. So in this, few will be satisfy the polynomial definition. Polynomial definition is that power should be positive integer. It should not be negative. If it is a negative, it is not a polynomial. This is not a polynomial. It should not be a fraction also. Only positive integers. Power is 3. Here power is 1. 3 and 1 both are positive integers. This is a polynomial. These are not polynomials. So polynomial means an algebraic expression whose powers of the variable should be positive integers. It should not be negative integer. It should not be a rational number or real number. Nothing. Only positive integer, then it is a polynomial. That definition already I gave. Once again I explained. You may get this in the bits. Suppose if some algebraic expressions are given, so which is the polynomial? If it is a negative power, not a polynomial. Fraction, not a polynomial. Suppose, see here, 3 by 2x square plus 5x plus 7. Is it a polynomial? No. Because x power 2, if you take into the numerator, it becomes x power minus 2. It is not a polynomial because negative power. Only positive power, it is a polynomial. Negative power, see suppose 3 root x plus 5. This is also not a polynomial because root x means what? X power 1 by 2. Root x is x power 1 by 2. So because of the fraction, it is not a polynomial. So that x variable should not be in the denominator. If it is in the denominator, nothing but negative power, which is not a polynomial. There should not be root or cube root or square root. There should not be any root for this. If it is a root, that is not a polynomial. So when algebraic expressions are given, you can find what is a polynomial and what is not. Clear? Can you recognize what is a polynomial, which is not? Which is a polynomial and which is not, that you can recognize. Positive numbers 1, 2, 3, 4, 5, 6, 7. Not minus 1, minus 2. Not minus numbers. Not fractions. Only positive numbers. This is a polynomial. Next. Second point. See, what is meant by term? Suppose if two expressions are separated by plus or minus, then we say that it is the next term. See, 2x plus 3y means it is two terms. Or x plus y is suppose 2x plus y. So we have two terms here. Plus is, when plus is separated, this is the first term, this is the second term. This is the first term, this is the second term. Similarly, if minus is separated, 2x minus y or x minus y, here also we say that this is two terms. This is two terms. But if they are connected by multiplication and division, then it is not a separate term. Suppose x into y, this is only one term. X into y is only one term. Suppose x by y is only one term. If it is a plus or minus, then second term starts. Suppose if this is plus something, plus 2, then two terms. xy means it is not two terms. Two factors are there, but term means only one term. This is one term. This is also one term. Plus something means if there is any number here, two terms. Following or not? So plus or minus, then we say the different terms. But into means, suppose x square y z q. This is only one term. It is only one term. If I write plus something, then it will next will be the second term. But if it is like this, into or divide x square y by z, it is only one term. Plus or minus, then only separate term. Following or not? Okay. So you can tell how many terms are there in the polynomial. So if a polynomial having only one term, suppose if only one term, it is called monomial. Monomial means polynomial having only one term. Plus something. This is two terms. When it is having two terms, I told this is called binomial. Binomial means a polynomial having two terms is called binomial. If it is having three terms, trinomial. Suppose plus something, so three terms. Three terms is trinomial. More than three terms is multinomial. Multinomial. Any number of terms, it is a polynomial. Poly means many. Polynomial means many terms. Many terms means, don't misunderstand that word. Many terms means even it is one term also we call it as a polynomial. Two terms also polynomial. Any number of terms, it is a polynomial. Poly means many, but there is no condition that if it is more than two, then only it is called polynomial. It is not like that. Again, it is divided. One term monomial, two terms binomial, three terms trinomial, more than three terms multinomial. But any number of terms, it is a polynomial. And after that, we studied one important concept, degree of the polynomial. Degree. Degree. See here. Highest power of the variable is called its degree. In a polynomial, the highest power of the variable is its power, its degree. So what is the degree of this? 3. 2x square plus 10x plus 25. Highest power of x power 2 is, there is no x here. The power is 1, the power is 2, so degree is 2. Only constant, there is no x here, so degree is 0. If there is no x, the degree is 0. Suppose if it is 5x, degree is 1. This x power 1, no, degree is 1. Degree 1, degree 2, degree 3, degree 0. But when this type of problems are not there in your in our textbook, but I will explain. When it is like this, what is the highest power? Highest power is not 3. See, this is only one term, no? When it is multiplied, we have to consider the addition of these two. 2 plus 2, 4. The degree of this is 4. So highest is 4, not 3. So degree is 4. This is some confusion, but you don't have problems in your exercise. But I explained. When this is one term, power is 1. This is one term, power is 3. This is also one term, power is 2 plus 2, 4. Even though they are different variables, we are not adding the powers. I am not writing x power 4. I am not writing y power 4. Only to tell the degree, we have to take the addition. 2 plus 2, 4 is the degree. Like that, if any polynomial is given, you can find its degree. Highest power of the variable is degree. But here 4 is there, 4 is the highest. Like that. What is the degree of this polynomial? 9. Don't see this coefficient. Only powers we have to see. 9 is the degree. Like this. See here. Next, suppose this is a polynomial. This is a polynomial. Say I represented this polynomial by p. If I take x is equal to 1. Suppose I am taking x is equal to 1. If I take x is equal to 1, 1 square minus 3 into 1 plus 2, 2 plus 1, 3, 3 minus 3, 0. 1 plus 2, 3, 3 minus 3, 0. So P of 1 is 0. For particular x value, if the polynomial is becoming 0, so this value is called 0 of the polynomial. This is very important concept. So we solve many problems on this model. 0 of the polynomial. 0 of the polynomial means the value of x, the value of the variable for which the polynomial becomes 0. The answer should be 0. For what value of x answer is becoming 0? For x is equal to 1. So that 1 is called 0 of the polynomial. 0 of the polynomial. For particular x value, if the polynomial is becoming 0, then that x value is called 0 of the polynomial. Suppose if P of A is equal to 0, then A is the 0 of the polynomial. 0 of the polynomial P of x. Suppose if the polynomial is say P of x. So in that P of x, if you take x is equal to A, in place of x if you take A, answer is 0, then that A is called the 0 of the polynomial. This is very important, 0 of the polynomial. If number is given, we can verify whether it is 0 of the polynomial or not by simply substituting that value in place of x. Suppose the value is not given. How to find the zeros of this polynomial? For 0 of this polynomial, suppose first I will take the first degree. How to find the 0 of this polynomial? 0 of the polynomial means you tell x value such that the answer should become 0. If you substitute x value here, this answer should become 0. So for what x value this is becoming 0? For 0 of the polynomial, this polynomial should be equated to 0. That means 5x plus 2 should be equated to 0. 5x is equal to minus 2. X is equal to minus 2 by 5. So this is the 0 of the polynomial. 0 of the polynomial. To find the 0 of the polynomial, equate the polynomial to 0, get the corresponding x value. So that is the 0 of the polynomial. If number is given, we can verify whether it is 0 of the polynomial or not by substituting in place of x. If answer is 0, it is 0 of the polynomial. If answer is not 0, not 0 of the polynomial. But to find the 0 of the polynomial, equate the polynomial to 0, we will get the corresponding x values. So suppose if it is a second degree, so we have to equate the polynomial to 0 to find the zeros of the polynomial. You know how to solve this equation. Tell two numbers such that sum is 5, product is 6. So 2, 3. 3, 2. 3, 2, 5. 3 into 2, 6. First 2 x common. Minus 2 common. So the factors are x minus 3 into x minus 2. So therefore x minus 3 is equal to 0, x is equal to 3, x minus 2 is equal to 0, x is equal to 2. Like this, if any polynomial is given up to second degree, we can find its zeros of the polynomial. First degree, it is very easy, but second degree, so you should know this factorizing model. That anyway, we solved many problems in this exercise, and even in the next few chapters also, we are going to get this type of problems. So you know how to factorize. Tell the two numbers, sum should be minus 5, into should be 6. Minus 3 minus 2 is minus 5, minus into minus plus 3 into 2 is 6. Like that we split. First 2 x common, next 2 minus 2 common, x minus 3 common, x minus 2. Like this. So like this we can find I explained about the 0 of the polynomial. Lot many problems we did. And after this, I explained division. Dividing one polynomial by other polynomial, that already I explained, and we solved many problems on this. See here. this is divided by x plus 2. How to divide? That I explained. In the quotient, take a number, take a term such that if you multiply with this, we have to get 2x cubed. Tell a term, multiplying with this, we have to get 2x cubed. So that I explained. See here, what we have to take? How to get 2x cubed? Take 2x square into x, 2x cube, x square into x cube, plus 2 2s are 4, x square. That means what we took? 2x square. 2x square into x, 2x cube, 2 2s are 4, x square. Subtraction. We have to subtract. Subtraction means all the signs of the second equation, second expression will change. Already it is plus, it will become minus. It is plus, will become minus. These two first term will get cancelled. Minus 7 minus 4 minus 11x square plus 5x plus 6. I took this. Now tell a number which should be multiplied with x to get minus 11x square. Tell a term which should be multiplied with x to get minus 11x square. Minus 11x. Minus 11x into x minus 11x square. X into x is x square. Minus 11 into minus 22x minus 22x. Again change the sign. Subtraction means we have to change the sign. Minus becomes plus, minus becomes plus. These two cancel. 27x plus 6. Then take 27 into x, 27x. We have to get this first step. Accordingly, we have to choose the numbers. 27 into 2 is 54. Subtraction. This plus will becomes minus, plus becomes minus. This is the remainder, this is the quotient. This is the division process, as I explained. Now, we can find this remainder without doing this process also. Suppose in place of x, suppose if I write minus 2. In place of x, I am writing minus 2. See here. X is equal to minus 2, x is equal to minus 2, x is equal to minus 2 plus 6. In place of x, I am writing minus 2. Minus 2 whole cube is minus 8 minus 16. Minus whole square, minus into minus plus 2 square is 4, 7 4s are 28. 10 plus 6. So, 30, 44, 54 plus 6 minus 48. See here, we got the remainder. Without doing this division directly, I got the remainder. So, the process of finding the remainder without actual division, that is, we call it as a remainder theorem. I applied the remainder theorem here. Now, I am explaining the remainder theorem. So, we can find the remainder without actual division by using some method. That method is called remainder theorem. It is used to find the remainders, but only when polynomial is divided by first degree term. Suppose if it is x square, so we can't find the remainder by this method. We have to do the original process only. Only when dividing by the first degree term, x plus 2, x plus 1, x plus 10, x plus something. Only when x power is 1, if you are dividing with that, then only we can find the remainders using this remainder theorem. So this remainder theorem is very, very important, and almost all complete exercise is based on remainder theorem, which we completed. That means that is I think 2.3 exercise. So remainder theorem, say here, if f of x is divided by or p of x, if p of x is divided by x minus a, then the remainder is P of A. This is the remainder theorem statement. That means if any polynomial Px is divided by x minus 2, then the remainder is P of x minus a, x minus 2, p of 2. That means take this x minus 2 is equal to 0 something, x is equal to 2. So x is equal to 2 here. Suppose if p of x is divided by x plus 2, then what is the remainder? If it is divided by x plus 2, what is the remainder? If minus gives plus 2, as per the theorem, plus will give minus 2. That is nothing but take like this. Take x plus 2 is equal to 0. Take x is equal to minus 2. So remainder is p of minus 2. So when polynomial is divided by p of x is divided by x minus a, remainder is p of a. This is the remainder theorem. This is very, very important, and we can find the remainder without actual division. So by using this, but it should be divided by the first degree term only. So like this, we solved many problems. Suppose if see here, x square minus 5x plus 6 is divided by x minus 2, find the remainder. Find the remainder. This is the question. If this is divided by x minus 2, what is the remainder? So I am taking the polynomial as p of x. So what I am doing? I am dividing p of x by what? P of x is divided by x minus 2. Then according to the remainder theorem, remainder is p of x minus 2 means p of 2. Because take x minus 2 is equal to 0, x is equal to 2. So find the p of 2 here. That is the remainder. P of 2 is 2 square minus 5 into 2 plus 6. 2 square is 4 minus 5 2 is 10 plus 6. 6 plus 4, 10. 10 minus 10 is 0. Remainder is 0. Like this, if one polynomial is divided by the first degree polynomial, then without actual division we can find the remainder. This is remainder theorem. Again, I wrote the statement which we have studied. Lot many problems we solved in this model. Next. Same remainder theorem concept only. If remainder is 0, suppose 25 is divided by 5. 5 5 is it? Say 20 is divided by 5. 5 4 is 20. What is the remainder? 0. If remainder is 0, then we say that 5 exactly divides 20. 5 exactly divides. Exactly means remainder 0. 5 exactly divides 20. We also call 5 is a factor of 20. 5 is a factor of 20. So factor means remainder should be 0. If remainder is 0, then we say that this x minus 2 exactly divides this. Or in other words, we say that x minus 2 is a factor of this. So that comes the factors theorem. Factors theorem means if remainder is 0, that means p of a is 0. Same statement in reverse I will read. If p of a is equal, p of a is 0, then x minus a is a factor of p of x. If p of a is 0, then x minus a is a factor of p of x. Suppose we want to verify x minus 2 is a factor of this or not. For that, take p x is equal to 2. If it becomes 0, then we say that x minus 2 is a factor. So that means after this remainder theorem, we studied very important concept, factors theorem. This also we studied. Exercise 2.4, we solved many problems based on this factors theorem. Factors theorem means if p of a is equal to 0, I am not writing in full, you write it, you just read it from the textbook. P of a is equal to 0, then x minus a is a factor of p of x. If p of a is equal to 0, then x minus a is a factor of p of x. We have to try. Suppose see here. this is a polynomial. Power 3 means maximum it will have 3 factors. It will have 3 factors. For example, 8, so for example 12 is there. So what are the factors of 12? 2, 2, 3. 2 to the 4, 4 3 is a 12. Factors of 12 are 2, 2 will repeat and 3. Like this, this will have 3 factors, maximum 3. Sometimes it may repeat, sometimes we may not have factors. So if it have a factor, it will have maximum 3, at most 3 factors it will have. So how to find the factors, that is very very important. How to find the 3 factors? For that we studied one important process, that is the factors theorem. Using this factors theorem, I explained how to find the factors. Take x is equal to some number so that it should become 0. We have to try. Suppose if I take x is equal to 1, x is equal to 1, you try whether you are getting 0 or not, you have to check. So this is becoming 0, then as per the factors theorem, p of 1 is 0, x minus 1 is a factor. That means x minus 1 is a factor. I said it will have 3 factors. So how to get 2 more factors? That means we can try like this, we can continue try with minus 1, try with 2. We can get the factors. Correct method is divide this polynomial by this x minus 1. You divide it, you will get the remainder 0. You will get the quotient here. If you factorize it, we will get 2 more factors. After getting one factor, divide the given polynomial by this x minus 1. You will get the quotient, no? So factorize it, we will get 2 more factors. So 1, 2, 3. 1, 2, 3. Like this. This is the process for finding the factors of a given polynomial. So that I explained, and in 2.4 exercise we solved many problems on factors theorem. So both remainder theorem and factors theorem, both are very very important. This is complete exercise. I solved each and every problem I solved, including examples. And factors theorem also I derived it, and I completed all the problems including examples based on this factors theorem. So next, the last exercise was very simple, that is identities. The last exercise 2.5 was very simple, no concepts, direct formula, direct identities. So we studied almost all the identities I explained, and even easy to derive also, I derived some of the identities. So the identities like a plus b whole square is equal to a square plus 2ab plus b square. That is the first identity. Anyway, you can any order you can follow. Then a minus b whole square also I explained. A minus b whole square identity. A minus b whole square is equal to a square minus 2ab plus b square. Third is, so this I explained, a plus b whole square. Even we derived also, this is one identity, and the second identity is like this. And another identity is a plus b into a minus b. All these are, we have written, don't write, just look at, this is a revision. So next, x square minus a plus b into x plus ab. So it can be written as x plus a into x plus b. This is also, we can use it as identity or directly we can do it. Next, I also explained the formula for a plus b plus c whole square, which is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. I also explained the formula for a plus b whole cube. A cube plus 3a square b plus 3ab square plus b cube can be also written as a cube plus b cube plus 3ab into a plus b. Two ways we can write. Then I also explained the formula for a minus b whole cube. A cube minus 3a square b plus 3ab square minus b cube is also equal to a cube minus b cube minus 3ab into a minus b. Next, I explained the factors for a cube plus b cube is equal to a plus b into a square minus ab plus b square. Next, I explained the factors for a cube minus b cube is equal to a minus b into a square plus ab plus b square. Next, I explained the factors for a cube plus b cube plus c cube minus 3abc. Very lengthy here. A plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. This also I explained. So all these formulas, identities I explained, and we completed this 2.5 exercise also. So all the 5 exercises, just we recollected what we studied. So polynomial definition, and after that degree of the polynomial, zero of the polynomial, and after that remainder theorem, and after that factors theorem, and after that some identities for factorizing the given polynomial for simplification. So complete polynomial, just a quick revision we did, and please go through it, practice it, and become perfect in this chapter. It is a lengthy chapter of course, and a difficult chapter also. Do a lot of practice and become masters in all the concepts, all the 5 exercises, examples, everything, and objective, including objective bits. So we uploaded the worksheets in the app. So many worksheets, and even IIT based questions also I uploaded in the worksheet. Please go through it and become perfect in this chapter. Thank you, students.